Okay, everybody. My name is Amber Freed. My husband is named Mark, and my 2-year-old twins are named Maxwell and Riley. In the summer of last year, our son was diagnosed with a pathogenic mutation on SLC6A1. Can I advance the slide?
I think so. Did you get the pop-up?
Yes, there we go. Okay, so that's us. Maxwell was developmentally delayed. He just wasn't advancing like his sister was. So after a lot of genetic testing, we received our diagnosis. And at that moment, I left a career I cared a great deal about and decided things needed to change, that something could be done for our children. And I founded SLC6A1. And when I tell you that I work on this, we figured it out the other day. I spend an average of 73 hours a week on organizing things, advancing research, fundraising. I work on this constantly. I am so dedicated to helping our children. And the mission of SLC6A1 Connect is to improve the lives of children and families affected through the mutation by raising awareness and funding to advance scientific research that will ultimately result in a cure for our children. As I mentioned, I started last summer, and some of our accomplishments thus far is that, one, we've received 501c3 status. We're a full nonprofit. We held our first symposium last November. You can see us in the picture there. We hosted 50 brilliant scientists from all over the world. It was such a cool experience. It was kind of awe-striking to be around that much brain power in one room. And the biggest thing I want to relay from that conference and everything I found is that we have so many reasons for hope. There are things on the horizon that I will talk about in the next slide, but there are new treatments every day. Then the next thing that we did was be connected with Simon's VIP. And I cannot thank everybody on the phone enough for helping us organize this and for your presentation today. For the patient community, if you could meet these people in person. The second I met the Simon's VIP staff at Global Genes this year and Dr. Chung, they just received an enormous hug from me, because these people get up and fight just like we do for kids with rare genetic conditions and for the autism community. We've raised over $200,000, this slide should be updated, toward our 2019 goal of raising $1 million to advance research. And while I'm doing all of this in the United States, Michelle and Cam Bassi are going down a parallel path in Canada right now. So for anybody on the phone from Canada, please connect with Michelle and Cam. They are some of the nicest, most approachable people with some adorable little children that you will fall in love with immediately. So next slide, on the horizon. Our goal is to advance a gene therapy treatment for our kids as soon as possible. I've set a goal for this organization that we will have a treatment next year. We're working with an elite group of scientists to make this happen. And like I said, fundraising like crazy to make sure the scientists have the funds to keep the research going. If there's one thing I could communicate to you all from a patient perspective, it's that engagement is key. One of the things that will be coming up is what's called a natural history study. And it will probably, it's all being worked out now. It will probably involve Simon's VIP in some form. And I can explain what this is further, but it's basically a study to help us understand the disease more. If we don't know who you are, it's very hard for us to connect with you, but this is the precursor to a clinical trial. So if you'd like to be involved, please, please, please let me know. You all have my contact information. Reach out to me directly. I respond to text even at 3 a.m. And in closing, I just want to thank Simon's VIP again. You are such champions for our community and just such lovely people. We appreciate you. And that's my presentation.
Thank you, Amber. And now I think we have a little bit of time set aside for the families to ask you any questions that they might have about your update.
Sure.
So for the folks on the line, just a reminder, if you do want to ask a question, feel free to unmute yourself, or you can chat me a question and I'll read it out for you.
Thank you. Thank you, Amber. It's Michelle Bassey from Vancouver, Canada. That was a great introduction. And we are so, again, grateful and excited for everything that's happening and everything you've brought together thus far for our community.
Well, thank you. And thank you for everything you're doing. Teamwork makes the dream work.
All right. If there are no other questions for Amber at this time, we will have some more opportunities for questions and answers if people do think of something later on the line. And in the meantime, we will go ahead and switch it over to Dr. Chung for her Simon's VIP update.
Great. Thanks, Lindsay, and thanks, Amber, for allowing us to work with you. We love your community and are always here to support in any way we can. Lindsay, I'm going to have you advance my slides if that's okay. So as I said in the introduction, I'm a medical geneticist, so I'm going to spend just a couple minutes talking about some of the genetics. So if you could go ahead, Lindsay, to the next slide. So when we think about our genetic information, we've got the instructions for the way our brains work, our bodies work, and within this, we've got about 20,000 genes that encode those instructions. When any of us have a child, and I've got 2 sons of my own, whenever we have a child, we give half of our genetic information to that child, each of us as mothers and fathers, and taking half from one and half from the other makes the whole. Next slide. When we do that, we are human. And what I mean by that is we have a lot of detailed information that's actually encoded by about 3 billion alphabet letters. So we have all of this information that we literally have to copy and paste. So copy over and send into the egg and the sperm that makes a new child. And I can say I've done this experiment. When you look at those 3 billion letters and compare a mother, a father, and a child, we don't do that perfectly. So out of those 3 billion letters, on average, we make between 100 and 200 mistakes in the genetic information we pass on to a child. Now, for most people, that genetic information where those 100 to 200 differences are don't end up being in places that are critical in terms of the way the body works. And so we tolerate that. And that's why we have as many people walking around, doing the things they do. But every once in a while, and that once in a while is probably something like about 1% of children that are born, one of those genetic changes ends up landing in a gene that's important in some way in terms of the way the body works. And we're here today because we're all connected in terms of one of those common genes. So next slide, Lindsay. So We think in most cases those genetic changes probably are present either in the egg or the sperm at the time of conception. From most of you, in terms of the genetic testing that you had that told you about the diagnosis for your child or your grandchild or niece or nephew, that genetic test result doesn't tell us what the original origin of that genetic change was, so we can't necessarily tell if it was in the egg or the sperm, or if it might have happened shortly after conception, shortly after that egg and sperm got together. Wherever it happened, however it came about, though, I want to reinforce and disabuse you of the notion that there was anything as parents that you did to cause this. So there wasn't anything, moms, that you drank or ate or used to clean the carpet or something you did at work. There was nothing you did that caused this, nothing you did or should have done to do this. As I said, this is just something that happens as part of being humans. Within this, for most individuals, because it's a genetically new event, for those of you who may be thinking about having other children, it's very unlikely it will happen again, but there is a small chance, about 1%, that it would happen again in a future pregnancy. And if people have questions about this, we can talk about it in the question and answer session, or you can certainly talk about it with your local doctors or genetic counselors. Next slide. So as Amber was saying in the introduction, for Simon's VIP, we're very much dedicated supporting communities with rare neurogenetic conditions that are, at least in some individuals, related to autism. And so we've tried to do this. This is at no cost to anyone in the community. And what we try and do is power the research community to get behind you all. So in other words, to be able to make it easy for you to be able to get your information in, whether it's information in terms of natural history information or specimens that are de-identified, so no one knows who you are when you participated, and then be able to get it out to as many researchers around the world as possible and do this completely freely. So completely free to your community, completely free to the researchers, but we want to make it easy for researchers to be able to study this condition and to do really good work. All of this in an effort, as Amber said, to be able to bring new treatments, new supports, better tomorrows to our families and to our young people. Next slide. So for those of you who have participated, thank you, thank you, thank you. We're going to be sharing back the data today that we have, again, de-identified, but from the community so that you're learning together. We also love to hear feedback in terms of, I have some of my own ideas I'll throw out to you guys in terms of where we probably need to go deeper and work with you all to get more targeted and focused information. And at some points, if you all decide to have additional meetings, whether they be virtual meetings or family meetings, we're glad to continue supporting and disseminating this information to you through that, and do this on an ongoing basis. Oftentimes we'll do this on an annual basis. Next slide. So in doing this, we hope that, like I said, we can educate you all in terms of doing this. I will make a point now and again in the future that for this condition, it's important for every one of you to be represented, that what drives researchers to work on conditions is knowing how common they are, how frequent they are, and knowing what the impact is. And so we want to have your voices heard, and I'm sure Amber would say the same. So we want to make sure that in the space of rare diseases, everyone gets counted and everyone gets heard. And we're here to be your megaphones. So for the information that I'm going to present today, so far, just to walk you through some of the numbers, so far we've had 19 families registered with Simon's VIP. One of the things we do within that process, and those of you who have been involved know this, is that we review your genetic test report. So we want to make sure that you're in the right club, that SLC6A1 is the right diagnosis for your child. And as we do that, we are, I would say, very rigorous to make sure that anyone that I'm including in the analysis today has unambiguously an SLC6A1 genetic change that we think is what we call pathogenic, or the cause of the behavioral and neurological differences. You'll see there's a drop-off between the 14 of you who provided lab reports and 11 of you who were very 100% certain. Those 3 of you that are not included may be eventually reaching the level of evidence that we're 100% certain, but we, as I said, do this quite rigorously. We take all your data in, we make all of the information available to researchers, but just to make sure that I don't mislead anyone, I haven't included those 3 individuals in the analysis today. But again, we haven't lost your data, and we still use it to drive the research forward. In addition to that, of the 11 people who provided their genetic test reports, 8 of you were able to get your medical history interview completed by the date that we set as a data freeze to be able to analyze the data for today's presentation. So again, if you weren't included, if you didn't make the February 15th deadline, don't worry, your data are still going to be used in future report outs as well as to the research community that are using this. So the one thing to be very sort of aware of is that means the data I'm presenting to you today are definitely limited. It's only based on 8 individuals. And importantly, and this was a question that came in from the families, those 8 individuals right now are ages 1 to 20. But importantly, and they're skewed, as you'll see in a little bit, to younger folks. Importantly, in terms of the longer term outcome and what this means sort of when you're in your 20s, 30s, 40s, 50s, 60s, we have essentially no information. And it's a big gap that we will try and fill with the community. But I just want to be clear that we're still obviously based on small numbers. Next slide. So what I've shown here on the left are the different mutations or the different genetic changes we see in the SLC6A1 change. And in the column on the right, the number of individuals who have that specific change. If you don't understand the gobbledygook of the letters and the numbers, don't freak out, don't worry about it. If you do understand what that nomenclature means, you hopefully will be able to see your child or your family members change there. But the point that I really want to make is the column on the right for the number of individuals. The point is that for almost every single genetic change, all but one of them, every single one is a onesie. So what I mean by that is everyone is unique within this. And as Amber, I'm sure, will be telling you when she goes out to try and talk to researchers about this, and as researchers try and decide how to model this or how to study this particular protein, they have to decide whether what they're going to study, which change they're going to study. It's important in terms of the treatments that Amber's working to develop with the scientists that we have as many different individuals represented, because it may not be that the treatments work exactly the same. It may not be that the differences are exactly the same. And so I encourage you, either if you see yourself on this list or especially if you don't, if your voice is not heard, if you're not advocating for your child or your family member, it's possible you could be left out in some way. And so both it's contributing the information for the natural history study Amber mentioned, and at some point in the future, I would argue also important to be able to get your blood cells, your cell lines represented so that they can be available for researchers to be able to directly study that genetic change. Okay, next slide. Again, the information I'm going to tell you about is to be able to help guide you and to share this with your doctors. One thing is that all of this information is going to be posted after today. So the recording, as Lindsay said, as well as the actual slides. Feel free to share this with your doctor, neurologist, therapist, educator. This information, again, we want to disseminate to the community. Realize that it's a work in progress, but we very much want you to use this information. Next slide. So the high level from this, not surprisingly, because I think all of you realize this, is that really what we're seeing is that this is something that is primarily affecting the brain. So as we see what ways it touches your lives, it's mainly in terms of developmental delays. We call it intellectual disabilities as the children get older, but it's basically problems with the way the brain's functioning, the ability to learn, the ability to be able to make advances developmentally. This is really in all dimensions, but we clearly see it in terms of language and communication. I'll get into that a little bit more. It is reflected in some individuals in autism, not everyone, but in some individuals. We see it also in terms of potty training and also some ability to focus or attention. Next slide. That's the sort of headline. I am going to talk about some more specific details, and epilepsy is one of those details I'm going to focus on, but I'm also going to focus on a couple other things just to make sure you've paid attention to them. And I think the families have, based on what we've heard from talking to you. So one thing I like to say is that for individuals that have neurological conditions, we want all the ways, all the sort of on-ramps coming into the brain to be working as well as they can. So in other words, I want all the senses to work as well as they can to make sure children are hearing well, they're seeing well, They are gathering information about their surroundings as easily as possible and unimpeded. That is, that there's not something preventing them from sensing or understanding the world around them. We have, other issues that we're going to deal with in terms of education, but we need to at least make sure that first step is all clear. So the good news is that vision in general is not an overwhelming problem, but we have seen what I would call minor problems. So we have had, again, look at the numbers. The numbers are small. Of the 8 children, individuals who've had a lazy eye or cross-eyed, that needed glasses because they had trouble seeing far away, but they could see near. Some issues in terms of the shape of their eyes called astigmatism. So the point is that if you haven't seen a pediatric ophthalmologist or someone who can examine your child's eyes, good idea to do that to make sure if they need anything that it gets taken care of. Again, because we want them to see the world accurately. Next slide. When we think about the issues that we see in terms of manifestations about the way the brain is working, we see that the muscle tone is low, they're floppier, they're looser, and I think all of you are working with physical therapists to be able to improve the core strength, and that's important and helpful. We also see problems with coordination of movement, and so I've called this movement disorder. And again, as far as I know, all of you are working with therapists in terms of gross motor, so things like running, jumping, walking up steps, things like that, as well as fine motor, so things that involve, for instance, being able to feed and use your hands and fingers. We have seen in terms of head size that for some individuals, the head size is smaller, so I don't want you to panic if you see that. That's something that we're now seeing in some individuals. Next slide. The biggest and the most important thing, and some families were asking ahead of time, what can I learn? What's most important for me? I think in this community, the thing that is an area of focus is seizures. So for all of you, we had seen some form of seizures. These are the technical different types or categories, and I think many of you appreciate these. Some of them are what we call petit mal, or seizures where it looks like your child is just zoning out for a little bit. They don't necessarily have any movements you can see, not necessarily jerking movements or generalized seizures, but they kind of look like they're dazed out for a little bit. Important, and I say this, and this may be even for future families who listen to this later, I say this because it's important to me to make sure families are getting EEGs or electroencephalograms to monitor how their child is doing with epilepsy, because sometimes it may be not quite so obvious every time they're having a seizure. There are other times when people have seen actual movements of the body, it's been more obvious. This has been in the form of drop attacks or myoclonic epilepsies, where you see some jerking movements, or simple partial seizures, where you'll see one part of the body manifesting. Thankfully, infantile spasms have not been common, although they have been seen in the community, and febrile seizures are, again, seizures associated with fever. So importantly, again, and I'll get to some of the treatments that you all have been using, seizures, important components of this. I think everyone in the group, at least everyone that we know of, has had the electroencephalogram. Video EEGs, so where they're actually monitoring on the video so that you can be able to, if there's something you're seeing and you're wondering if that's a seizure at the time, you can hit the button and be able to see the correlation with the brain waves and see how that's correlating, as well as I'd encourage 24 hours. So to be in the hospital overnight, allow your neurologist to get a very good picture of both daytime and especially nighttime during sleep, whether there's any seizure activity that you may or may not be aware of. And for many of you, you're continuing to work with your epileptologist, and that's appropriate to continue monitoring with those EEGs. So that's, again, a headline important point to take away. Next slide is that we have seen, I would call them relatively minor features for the most part. I'm not saying they're not impactful, but we have seen issues in the tummies in terms of constipation, to a certain extent, reflux. To me, that's a reflection of low muscle tone in the intestine, so things are moving along slower. Many of you are using either natural methods or dietary interventions, or in some cases medications, to be able to help things move along, and that has been helpful. Next slide is that we have seen some issues, relatively minor and infrequent, but in terms of gaining weight and growth associated with that. Again, it hasn't been overwhelming to a certain extent. I think these are age-related with things getting off to a start at the beginning. So just to be aware of this, but again, not a major issue that we're seeing so far. Next slide. We have asked you about surgeries, and for the most part, I would say the surgeries have been relatively average kid stuff, so to speak. There haven't been things that have been specific to this condition that I don't see just when I see general kids in terms of needing ear tubes or adenoidectomies. I do think it's appropriate if there are recurrent ear infections to be able to help clear those ear infections because, again, getting back to what I said about being able to see and hear clearly, especially important in terms of language and learning language. And this is especially true early on in life when that part of the brain and speech are developing. Otherwise, the good news is haven't been, as I said, serious medical concerns outside the neurological concerns. Next slide. So to think about another form of treatment, and this in terms of not just surgery, but medication, for individuals, medications have been common in terms of the need specifically to control epilepsy, and that's absolutely appropriate. We want to get seizures under control. To a certain extent, as I said, people have used medication for some of the constipation issues or some of the behavioral issues, specifically the attention issues. So with this, again, and I want to highlight, things have definitely been better with those medications. Next slide. So I know the families have been talking amongst themselves, but just to reflect back to you, at least what we've heard from the Simons VIP is that, again, medications people have started basically as soon as it's been recognized that seizures were in place. I actually take it as quite a positive thing that, number one, several different medications have proven to be effective in the community. With that, in many cases, there actually has been seizure control, and in some cases with single medications. And some of you may not appreciate it, but that's actually, to me, a really, really good sign. Some individuals, I realize, there may be different times at life, and I don't think we know the full natural history. But I will say for those of you who may have kids that are starting to age up into the adolescent period, that's one time frame where we become more vigilant about seizures perhaps changing in terms of the nature, either even if someone had been off medication, needing to start medication again, or perhaps change medication. So just keep that in the back of your mind. I'm not saying this because I know this based on data coming from the community, but this is just a general thing that we see in general with neurogenetic conditions. But again, I wanted to list specifically these medications either for the group today or for families in the future to at least see what we've seen so far in terms of specific medications. What I anticipate we're going to do with the community, unless you tell us otherwise, is to drill down much deeper now in terms of the direction of epilepsy and to gather additional information. And Amber may be doing this through other things she's thinking about through the natural history, but for Simon's VIP, at least that's what we have to offer for that. So in summary, in the next slide, really the challenges, like I said, are focused. Next slide, Lindsay, if you can. The challenges are focused in terms of neurological issues, developmental delay, learning disabilities. One of the points I want to make is that the children, certainly in terms of even if expressive language is difficult, they are understanding and receiving a lot of information that you may not even appreciate. So don't underestimate them. Don't sell them short. Continue to work, and we're going to talk about this more a little bit with the next talk, about ways of being able to augment communication and being able to help support your children. But my main point that I want to make is don't sell them short. Continue to talk with them, read to them, sing to them. Singing, I actually think, is a great way to help in terms of helping their speech development. And I would suggest also using alternative methods of communication beyond just speech. And as I said, there are a few other things. Pay attention to them because we want your kids to feel good, but in particular, some of the gastrointestinal issues. So I'm going to give, next slide, just a tiny little bit in terms of some of the science behind this. I'm not going to go too deeply because we don't have a lot of time today and I want to save time for questions. But just to appreciate that the reason why this genetic change causes brain changes and specifically brain changes is that this is a carrier or a transporter specifically that transports what we call a neurotransmitter or one of the chemicals that is communicating between one nerve cell to the next nerve cell in the brain. And so GABA in particular is a major inhibitory neurotransmitter. When the brain is not appropriately inhibiting some of the excitability going on between the electricity going on between one brain cell and the next, there is too much electricity flowing through the brain. And when that happens, that there is too much electricity, that essentially is what a seizure is. And so therapeutically, the goal is to dampen that down, make sure there's not too much electricity flowing through, and just the right amount of electricity so that that message goes from one brain cell to the next, and that communication, that signal has greater fidelity. And that's what we need to do to both make sure we're not having seizures, but also to make sure the brain is working. That helps learning, that helps memory, that helps behavior, that helps the brain function the way it should. Next slide. So this is just meant to be a very brief overview. And again, I'm not going to go through it in detail. But what Amber has worked 73 hours a week on tirelessly, and she is just amazing, I have to say that, is to really build many of these foundational pieces to be able to get the community onto a therapy. And I won't go through all of it, but you'll notice that what we're trying to do is identify more individuals with the condition. We work with the clinical laboratories, we work with research studies, we have a program called Spark that's trying to identify more individuals, but we want to have a place that we can be able to advocate for diagnostic testing. And so I and others do a lot on the policy side by making this available to more and more families, and we hope we can do that at the beginning. One of the families had asked how common the condition is or how many are in the UK. I actually don't know how common the condition is around the world. My guesstimate, although it's simply a guesstimate, is that it may be something on the order of 1 in 100,000 babies that are born with this condition, but I could be off certainly by, even as much as tenfold. But based on what we've seen currently, that's my best guess. We are trying to understand the natural history. So what that means is that we're not just collecting data from the families the first time we hear from you, but really continuing to do this on an annual basis. And I said, make that information available. We're trying to develop what I call reagents or tools that researchers can use. That's largely in the form of blood samples from families to give us cells that, again, in a de-identified way, the researchers can use to model your child, ultimately so that they can test new treatments and get to the points of what we call clinical trials or developing new treatments. It's a ways off, but that ultimately is what we'd like to be able to do. In the last slide, as Amber said, she's working towards really molecular approaches, ways to be able to get the SLC6A1 gene working better, whether it's replacing it, whether it's fixing it. It's a tall order, but I do want to say there is, I think, great hope for this. I predict that there's going to be one major disease that the FDA is going to approve for gene therapy, at least in the United States, by the end of the year. And I see a lot of activity in the research community, both in terms of universities and hospitals, but also companies that are working to make this a reality. So I think you guys are exactly on the right track. So let me stop here, and I think there may be time for a couple questions, and then I'm always happy if questions come up later. We're happy to, just by email, Lindsay will help us aggregate those and send those back to the community.
Thanks, Wendy. And really quickly before we launch into questions for Wendy, I just want to have, I had one question come in for Amber asking about what was going on presently with preclinical trials and if there are any results. So Amber, if you want to chime in on that.
Yeah, absolutely. Before I even answer that, I can answer one of Wendy's questions about prevalence. So that information actually is under peer review, but we are on the prevalent side of rare disease, if that makes sense. We're actually 1 in 38,000 live births, which equates to about 100 people in the US a year and 3,500 worldwide. Of course, the UK and Canada are much smaller, so think about it like that. We are the 10th leading cause of autism right now, of discovered genes, and the 6th cause of generalized epilepsy. And all of that information will be disseminated pretty soon. I've just read the initial research. Then about the status of the clinical trial, there are gene therapies that I expect will be approved this year for much similar diseases, and we are piggybacking entirely off of what they are doing. We're underway in preclinical testing for gene replacement therapy with a goal of getting the treatment into humans next year. And I could talk about the actual therapy itself and the ins and outs and how it works for hours, but I don't think anybody wants that right now. If you would like to learn more, I regularly post tutorials on the Facebook support group, send it out via our newsletter, and also always feel free to reach out to me directly. And sometimes it's more easy just to explain it like a human than even read about it. The bottom line is that the science is looking extremely promising, and there are so many reasons to be optimistic. The other unfortunate reality about what we're doing is that this research is ungodly expensive, like upwards of $1 million that we need to raise, that we are responsible for. Nobody is going to just come and help us. And if we don't raise the money, everything that we're doing could come to a screeching halt. And that's just a reminder for everyone. If you're involved in anything nonprofit or charity, please consider raising money that will go directly to your child. I take no salary. I don't even cover my personal travel expenses. Every penny we raise goes directly toward research. As a cool example, Cam and Michelle's family held a lemonade stand just last week that raised $800. Most importantly, I think that the message that I would like to convey from the patient organization side echoes Wendy's sentiment that if parents aren't involved early and often and responsive, you do run a very high chance of being left out entirely. It is imperative to work with the nonprofit group, your clinician, with Simon's VIP, to get your child's information disseminated in a timely manner. As a patient group, we need to make our gene a no-brainer for scientists to want to work on. We need to show that we're organized, energetic, and that we're easy. And if those three pieces fall in place, I really think we'll be able to advance the science so much faster. The other thing I wanted to say, and this is for Simon's VIP too, about the prevalence of our gene. You know, I think all of us thought that we were this ultra, ultra rare condition when we started. But the disconnect was we were newly discovered. So we only made the major genetic testing panels in the year 2017. So up to that point, how could you be diagnosed with something that the doctors didn't know existed? You can't. So one of the major things I've been doing this entire year is to make sure that genetic testing companies know our gene exists and what panels we should be on. And we're still only on 13% of genetic panel tests. So as more and more people are tested and finding us, our patient population is going to grow at the same rate. And that's it for my questions. Yeah.
Okay. So Lindsay had just sent me a few questions maybe that people texted or had beforehand. So I just want to go through a couple of them. One question is, why do some parents have the same mutation as their children but are unaffected? There is a possibility, and anyone that has this specific question, I'm glad to talk with you offline, or I'm sure your geneticist as well. One possibility is that the parent may not have it in all the cells in their body, and in particular, they may not have it in their brain cells, and that's why they may not be affected or maybe, you know, very mildly affected. I also will say that, and this again goes back to my point about I want to make sure everyone's actually in the right place or in the right club, there's a small possibility that this is not the right answer, and that, you know, if you share the same change as your child, there's something else that either you don't share with your child or something else that's the answer. So like I said, either just you may want to make sure that this is the right answer for you. There's a question in terms of why do some individuals have the same mutation but different symptoms. Within the changes, and again, I want to emphasize, almost everyone is the only person with their particular change. They may not all affect the transporter in exactly the same way or the same degree. So this may be a continuum of differences, but as I said, there may be differences both in severity and even how it manifests in terms of at least some of the behavioral differences, because they may not all be as severe, or even some of them may be slightly different in the way they affect the gene. For that reason, it may also be that the same drugs don't work on everyone in the same way. And again, because everyone sort of collectively falls under the same gene, the exact way that that gene is working or that protein is working, because the changes are different, may be different in different individuals. Again, I can't emphasize this enough, is that you have to represent yourself, because if there are differences, the next person, you know, in the community may not actually adequately represent your child. So within this specifically, why do some individuals have autism and others don't? I will say that this is based, again, on who's been evaluated, what parents have reported to us. There are all sorts of differences that I won't go into in terms of even around the world, what evaluations clinicians do to make a diagnosis of autism, some of the reasons individuals get a diagnosis. And we have not, in this study, taken everyone and put them through with the same evaluators to see exactly how people line up compared to each other, but at least the way parents reported to us, and based on how old their children are now, we do see, you know, that not everyone carries an autism diagnosis right now. What I do think is universal in the group, though, like I said, is delays in terms of development that seem to grow across all dimensions. So I hope that answered those questions.
I have a question that came in through chat. This person wants to know if there are any cases that have shown regression.
Regression is a bit complicated. What we have seen is that when individuals are having problems with their epilepsy and their epilepsy is not controlled, they can have problems with development and either stagnation or regression with that. What I have not seen, although, like I said, I don't pretend that we've seen everything yet with this condition, what I have not seen is that individuals regress and continue to regress and permanently sort of go downhill. So I do think one of the important things, again, is to make sure seizures are under control, and to, even if there's sort of temporary regression, to make sure that kiddos go back on the sort of going back uphill, you know, being able to make positive gains in development.
Thanks. Another question that came in through chat is somebody wanting to know if there are any cases where the epilepsy resolved.
My understanding was, yes, there are cases in which individuals have both been treated well with medications and, you know, so resolved in that way. Definitely, you know, seizures stopping in terms of that. In terms of permanently outgrowing, I guess my hesitation to say anything in a permanent sort of way is most of our kiddos are still quite young. And so I think we still have other phases of life to go through, and I'm not confident in saying that seizures, you know, we can say for anyone that seizures have gone away permanently and forever.
Hi, Alex Iblanet speaking from France. I have a question also concerning the therapy. Do you think that this would be applicable for all ages? Or
are you talking about like a gene therapy that Amber was talking about?
Yeah.
So Amber, you know, I can let you chime in as well. I do think as a general rule, when we think about gene therapy, and I think about this for many conditions, in general, earlier is better. But I think there's going to be a window for this for potentially, if it works, for anyone of any age.
Okay.
Amber, do you want to answer as well?
I'm sorry.
That's exactly, I would answer with exactly what you just said, is that of course, the earlier you're treated is better for most conditions, but that doesn't mean that other conditions aren't seeing an improvement in mice at other ages. Again, the important thing is that the more we're able to look at your affected loved one's information, we will be able to see. The other thing I wanted to mention just to everybody on the line is that for those people who are not able to attend today, it would be wonderful if you can help me get the word out that there was a lot of helpful information on this. And I just want to say it as many times as possible on the recording. We want you involved. Please become involved. Encourage everyone else to become involved.
Thank you, Amber. I have another question that came in through chat. This person wants to know what your thoughts, Wendy, are on if a ketogenic diet might help with the SLC6A1 kids.
Yep. So for many of the families probably know about this, but for some forms of epilepsy, we will change the fuel source for the brain, and children will be on a ketogenic diet that has no carbohydrates at all, so no sugar, and it's a very, very rigid, very specific diet. At least in my experience, and certainly if anyone else has a different experience, chime in, it's not obvious to me that a ketogenic diet physiologically should sort of take care of this problem and be the only treatment. Sometimes we will use a ketogenic diet when children have failed other medications, but the general sense that at least I get is that this would not be, there are enough other alternative medications that seem to be working that I would try and do those first, just because the ketogenic diets are difficult. Now, for some of you, the optimal sort of, there are two things I look for in terms of controlling seizures. One is to be able to control the seizures, but the other is to make sure that a child is not so sleepy or out of it that they're not able to engage with the world and to learn. And so it's that balance of things to be able to achieve. If you feel like you're not achieving that good balance or one portion of it or the other, definitely talk with your neurologist. There are, as I said, ability to use different medications, combinations of medications, or a ketogenic diet can come in at that point. But if you do a ketogenic diet, it should be under the care of a neurologist, a dietitian, that's a real ketogenic diet. It's not just sort of increasing the amount of fat in your diet.
Thanks, Wendy. I have another question that came in via chat, and we have Chris on the line. He's a coordinator for Simon's VIP. So I'm going to have Chris answer, but this participant wants to know how they can get blood samples to Simon's VIP.
So we recently partnered with Quest Laboratories for collecting blood for our repository. So if you would like to participate, you can send us an email about it, and then we would email you questions about who all would be interested in having the blood draw and weights for younger children. And then we would get the kit ready and we would send it out to you with instructions to schedule a blood draw at a Quest center. And also in the kits would be the required paperwork for the Quest center. So it's pretty easy to find. You can go to any Quest center that's closest to you, and the links that we send after we create the blood kits will have all the information that you need to schedule your appointment and all the things that you would have to bring to your appointment. So if you would like to do a blood draw for our repository, you can reach out to us by email and we'll get you all the required stuff and then send the kit out as soon as we get it done.
And Chris, notably, that's specific to people living in the United States. Is that right?
Yes. For biospecimen collection for international participants, we do saliva. Thanks for clarifying that.
That just answered my question. Hi Chris, that just answered my question because we're in Canada and I received the kit. I haven't opened it, but I wasn't sure the details of how to get that to Simon. So that's great. I just have one or two other quick points. They're not necessarily questions. They're not necessarily, actually they're for Wendy. Wendy, hi, thank you so much for everything thus far that you've explained. It's been really, really helpful. I wanted to just touch on one quick thing, which was the EEG. And you said the importance of the 1 day in hospital, potentially overnight, in order to capture potential seizure. For my son, we had 3 EEGs that showed no seizure activity that were just 1 to 2 hours in hospital where he was sedated. So but all 3 times they did not record a seizure. It wasn't until our 4th EEG, and again, we're in Canada, so it was a 5-day inpatient, so he stayed in the hospital with me, and it wasn't until the 4th or 5th day that it recorded a seizure, and that was because they had to wean him off his medication, and that was the only way that they finally had confirmation of a seizure. So it took longer than 24 hours. It took 4 to 5 days.
Right.
That was
thank you for that. So obviously, if you or your doctors have suspicions and need to do things other than what I said is sort of a general guidance, that's absolutely the case. The standard, and again, it's at least in the United States, is that, to do for standard sort of evaluations to do 24 hours, that gives us a chance to see both during sleep and during wake, and sometimes people will even try and provoke a seizure, by doing sleep deprivation or other things. But if you or your doctor feel that there's need to go longer than that usual guideline, by all means, follow your doctor's advice in that. So I'm glad you got what you needed to eventually, although it sounds like it was a long time in the hospital.
Well worth it though. Yes. Yes. Thank you. I think that was my only point that I wanted to just mention.
Thank you.
Okay, then this one is just a follow-up to when Chris was talking about the blood samples, which is what is the purpose or benefit of sending in a blood sample?
So I'll say, this is Wendy Chung. I didn't really go into the details, but one of the things that happens with your blood sample is we can use the cells to be able to make what are basically brain cells in a dish. So without having to do something like a brain biopsy in your child, without having to do any sort of fancy genetic engineering, we can literally represent your child's brain in a dish. And by us, I don't mean we specifically or me specifically, but the research community can do this. And as an example, if they wanted to test a new form of gene therapy, a new medication, something else, they would be able to do this in your child specifically. And so in addition to that, there are other things that they may do in terms of being able to see if there's a bad side effect, if a particular medication might do something and have what they call an off-target effect or an unintended consequence. It is literally having your child or your family member represented within those studies so that scientists will be working hard for you. And that's what I meant about the representation. If you do that, the whole point of what we try and do on Simon's VIP is that you don't have to keep doing that over and over and over again. We can just do it one time and be able to distribute it to as many of the researchers who we can. And as Amber said, it's a way of being able to entice researchers who might not otherwise be interested in this condition to get interested in this condition, because you guys make it easy for them to make progress, and they feel like they can make progress. They can come up with new treatments. So you help them. You meet them halfway.
Thanks. And I had a question that I think we covered in a slide, so I can navigate back to it if that would be helpful. But we had a participant ask if there are best seizure medications for controlling or reducing seizures.
Yeah, so again, we'll make all of these available in terms of the slides that I talked about. I think there are a couple medications that seem to be working better. I guess I don't want to take the place of your own neurologist, so I would take the slide deck to your neurologist and see what they feel about your particular child. If the medications that I had showed on the slides look like they might be helpful. The impression that I had been getting in terms of medication that might be working is clobazam seemed to be working for a couple of the families. Valproic acid, which is another standard one, at least seemed to be working, if not completely, at least in part. So those would be two anti-epileptics that I would think about specifically. But again, the most important thing is go to your neurologist, your epileptologist. They know your child better than I do. But feel free to share this information with them.
Thanks, Wendy. And then as the last question, we'll need to move on to the next presentation. Wendy, would you be able to talk just very briefly about what's going on with like Rett or Angelman in terms of like gene therapies?
Yeah. Rett and Angelman syndrome are a bit complicated and not entirely analogous to this transporter. So Rett and Angelman syndrome, and I apologize for getting a little complicated, but there are Angelman syndrome children with that have one copy of the gene that has been silenced or quieted, and another copy of the gene that's sitting there that could be used but is not active. And so some of the strategy in Angelman specifically is to be able to take that copy of the Angelman syndrome gene, the UBE3A, and to actually activate it, to wake it up, to get it working. And so there's a very different strategy than what people would be working on in terms of this community's condition. Rett syndrome is kind of a same thing. It's complicated because it's a condition that's on the X chromosome and it tends to be in girls. But again, one of the ideas is that there's a second copy of the gene that's perfectly fine. The A's, the T's, the C's, and the G's are perfectly fine, but you need to wake it up. You need to activate it. And so it's a different mechanism, but it is a form of gene therapy or gene manipulation. I think there are some sort of details, and again, Amber has posted some things, and she and others, I'm sure, could do entire webinars just based on this. But one of the questions I think for the community is going to be, with the genetic manipulations for this, is it going to be a gene addition? In other words, adding some more of the gene? Is it going to be technically trying to fix the gene? That's a bit more complicated. So I don't think that's going to be ready quite, within a year. And so we would call that gene editing, or, sort of fixing the gene that's already present. So it's complicated, and you want to make sure that you get just the right amount of the gene there. If you get too much, there could be issues. If you don't get enough, there could be issues. So it's going to require, some time to develop this and make sure it's safe. And there are several steps that go through with that. So as Amber was talking about, part of it's with cell lines, part of it's with animal models, and then part of it ultimately is in people. But, very, very, a lot of movement, a lot of positive activity, not just because of this gene, but because many, many other genes in this whole method is being studied on large scale.
All right. Thank you so much, Wendy, and to everyone for your great questions. We're going to move on to the next part of our presentation, which will be presented by Elizabeth.
All right. Well, thank you very much. I want to say again, thank you to Lindsay and Amber and Wendy and Simons, and to the community that's here. It's always so inspiring to hear how people are working together to advance our understanding and advocate on the behalf of loved ones. So thank you to everyone who has been teaming up to lock arms together around such an important issue. I wanted to start off today by just giving you a brief overview. Let me see if I can just change slides. There we go. To give you a brief overview. So we're going to start and talk a little bit about what applied behavior analysis is. I know that there may be kind of a range of understanding on this issue or on this type of treatment. So we're just going to give some brief information on that. We'll talk about some of the basics of applied behavior analysis, some of that terminology and language that you might hear in terms of some of the basic concepts, and then dive into a little bit about how we can teach skills through applied behavior analysis. So what is ABA, or applied behavior analysis? And what it is it's the science of learning. And what the field has done has looked to identify and describe principles that govern learning for all people. And I like to emphasize that because while it has been particularly effective in the treatment for individuals with autism spectrum disorders and other developmental disabilities, these principles and the way that ABA teaches skills are good for everyone. And so just a quick example, would be that a person is going to be likely to repeat a behavior when it's followed by a positive outcome. So for example, if you have your very favorite coffee shop that you go to where they make your drink just the way you like it, you're going to be more likely to continue to go to that particular coffee shop so that you get that positive outcome of getting the coffee made the way that you like it. So these principles are happening all around us all the time, regardless of whether or not we're really paying attention to them. But when we kind of shift gears and look at how ABA is used as a treatment approach, what we're doing is looking at how we can use these principles in a very intentional way to create learning and increase skills, or look at using it to decrease potentially unwanted or more challenging behaviors. So the definition of applied behavior analysis is just that this is a process. It's a scientific process that we're using to systematically apply interventions using these principles of learning that we've kind of uncovered and defined to help improve socially significant behaviors. And when we're talking about socially significant behaviors, we're talking about the things like communication skills and adaptive skills that are going to be really meaningful and beneficial to somebody's life. And one of our goals in ABA is to demonstrate that the interventions or techniques that we're using are what is responsible for that behavior change. So when we look at using ABA in terms of the treatment of autism, what we're looking at is using it to help improve core symptoms of ASD or other developmental disabilities. And so oftentimes you're going to hear that services are being used to support the learning and skill development of, oh, I think the slides are jumping. There we go. Sorry about that. The skill development that helps to positively impact a variety of domains. So things like social skills, being able to greet peers, interact with peers, have reciprocal conversations, which kind of leads into some of the communication skills that we may target. If you have younger children, you might find that therapies are helping to improve play skills, certainly behavioral skills, so helping children to learn to tolerate frustrating situations, adaptive skills, motor skills, and even cognitive skills, so that we're helping to have children learn all sorts of foundational skills that are going to really help them be set up for success later on when they're learning more advanced skills moving forward. One thing I always like to be pointing out when we're talking about this is that we are always partnering with other specialty areas when we're looking at this. And so I really like to emphasize the importance of a multidisciplinary approach because ABA is not a standalone treatment. I know that in my program, we're constantly collaborating with psychologists and the doctors and speech and language pathologists. Oftentimes, we're communicating with people out in the community, so maybe some of their educators. Certainly the case that we're working with physical therapists, occupational therapists, and most importantly, the family, because your input in helping to design treatment and determine the social significance and impact of the interventions is crucial. So again, this is why, you know, we have parent education and collaboration be such a huge part of the programming that we do over at the Autism Center. So again, just quickly, what is ABA? ABA is just looking at the relationship between the behavior and the environment that kind of govern those behavioral changes in all of us every day. And that's just learning. So in the example that I laid out for you, a very common one that we see on a regular basis or have parents talk to us about a lot is, you know, maybe a child is tantruming in order to try to get a toy that is out of reach, and we teach the parents not to give them the toy in that case. And on the flip side of that, a child might learn to ask really nicely for that toy that's out of reach, and then they get that toy. So in that situation, they learn that maybe when they're tantruming, they're not going to get what they're looking for. But if they're replacing that tantrum by using their language or a different way to communicate, because it certainly doesn't always have to be expressive or vocal communication. It could be pointing, it could be an AAC device, something like that. But when they're using a skill like that, they're going to be able to contact and obtain the item that they want. So ABA is just looking at systematically applying these principles of learning that we're going to talk a bit more about in the next couple of slides to purposely change behavior. So now that we know what ABA is, now we're going to talk a little bit about how do we do ABA. And while this is a much lengthier conversation, we're going to just go into a few quick concepts just so that you have some orientation in terms of the next portion of the talk as well too. So oftentimes you're going to hear about this ABC sequence or the 3-term contingency. And what that means is that we have an antecedent, a behavior, and a consequence. And so all an antecedent means is whatever happens right before a behavior that kind of cues or signals the behavior to happen. The behavior is just the response that a person engages in. And a consequence is just what happens right after the behavior that makes it more likely or less likely to happen again. And I like to point out that consequence doesn't mean bad. Sometimes when we're looking at ABA terminology compared to how we might think about those words in the English language, sometimes that can be confusing. But again, consequence just means whatever happens right after the behavior that might help it to happen again or to make it less likely to happen in the future. So another just quick example is in this scenario, an antecedent might be mom asking a child, what do you want? And a child saying goldfish, and the mom giving the child the goldfish. So in this situation, hopefully the child is likely again in the future to say goldfish because they were reinforced by getting that preferred item within this 3-term contingency. So the reason why we like to talk about these ABC sequences is because this is how we are able to design interventions to understand and alter the environment that a child is in order to change behavior. So again, these contingencies are naturally occurring all the time. This is how you and I are learning a whole bunch of things constantly, but we're looking at controlling these contingencies or making changes to these sequences in order to purposely create learning. And this is what ABA is. So there's 2 main focuses. We're either looking to increase desirable skills, really creating learning opportunities for individuals, or we're looking at decreasing some of the undesirable behavior. So looking at maybe reducing disruptive or maladaptive behaviors. And again, we're doing this by understanding and altering the existing ABCs of a behavior. There are three basic principles of ABA, and I'm sure you can, we're not going to go into too much detail, but I'm sure you can kind of think through some of these things for yourself potentially. The first one is reinforcement, and all this means is that reinforcement increases the likelihood that a behavior is going to happen again. So we do this either through what you're going to hear referred to as positive reinforcement or negative reinforcement. And again, I just like to remind people that these words positive and negative don't mean good or bad. Positive just means we're adding something or giving something to an individual, and negative just means we're removing something. So an example of positive reinforcement would be saying something like, great job, or, you know, giving a child a toy that they asked for, or giving the child goldfish like you just saw in the previous example. And negative reinforcement would just be removing something from the environment. So removing maybe a aversive situation. So, you know, maybe your child learns to ask a peer to stop, you know, playing with their toys or knocking down their tower, and they use their language to stop that aversive situation of having their toys or their play being interrupted. That would be negative reinforcement for them to continue to use that language or communication in the future in order to get their needs met. On the flip side of that, we have punishment. And punishment, again, often has kind of this negative connotation. It doesn't necessarily mean bad. It just means we're looking at decreasing the likelihood that a behavior is going to happen. So again, there's going to be positive punishment and negative punishment. But what I like to just point out here is that there are always ethical considerations when you're using any of these principles of learning. And as analysts, we are held to an ethical code where we are always supposed to be looking at reinforcement procedures and embedding reinforcement into interventions and treatment for your children before we're even considering the use of punishment procedures. And the last principle is extinction. So extinction is when we remove specific reinforcement that was previously available to an individual. So let's say that we have Robert and he is trying to gain attention from the people around him, but he's doing it in a really inappropriate way and kind of misbehaving. If we were going to put that behavior on extinction, or that's how we would refer to it, we would look at no longer providing attention to Robert when he was engaging in the inappropriate attention, but then we would look at teaching him skills and teaching him other ways to gain attention in a more appropriate way. And so the benefit of using extinction is it helps to decrease the likelihood that challenging behavior or maladaptive behavior will occur in the future. Again, just in terms of ethical considerations, I always like to point out when we're talking about basic principles that oftentimes you're going to hear about what's called an extinction burst if you're using a procedure like this. And that just means that there might be an increase in duration or intensity of behavior before it starts to get better. So again, this is something that, you know, you as the family, in addition and in collaboration with your team, should really be deciding upon together before you're implementing any of these types of procedures. So now that we've talked a little bit about some of those principles, now we're going to look at how those can be applied when we're looking at teaching skills and thinking about the process of ABA. So we're going to focus a little bit more on ways we can target intervention to teach new skills in order to increase those appropriate behaviors and decrease inappropriate behaviors. But before we jump into that, I want to provide a brief overview of what the very basic process of applied behavior analysis looks like. So, you know, typically we're starting with assessment and identification of target behaviors. And this assessment helps us to develop goals in collaboration with the family about what we think is going to be really beneficial to that individual. And then once we've decided upon that, we look at designing and implementing different interventions that are based on all of those principles that we were just talking about. Then we're going to be looking at how we're collecting data on those interventions in order to determine the effectiveness of treatment. And then from there, we're looking at using that data to evaluate what's happening and making any kind of modifications as needed. And then once a child is making progress in ABA, we are at some point always going to be going back to assessment again too, and be measuring growth and progress there. You know, I often have parents ask, you know, how do we know what we should be doing, or how do we know if it's working? And this is all embedded right within this cyclical process. Your child's team should be using an assessment to determine which skills would be beneficial to teach that are based on evidence-based practices. So that just means that there is good research behind the interventions that are in place that show that they are effective in treating or helping to teach that skill. And then they should be showing you how they're collecting and monitoring the data so that you know it's working. It should be a very transparent process. And that's often a big part of the education that we do with our families, is teaching them how to be savvy consumers of ABA, so that they can be sitting right next to us and analyzing those graphs right beside us so that they can see the progress that their child is making. I also like to point out that ABA can be applied broadly to many areas. So again, I know you're hearing me talk more specifically about the treatment for ASD or developmental disabilities, but ABA is used in all sorts of areas, such as education, organizational behavior management, health and exercise. It's been used in industrial safety, medical procedures, environmental conservation. So again, I really want you to think of it more as a scientific process, and something that it's just good teaching, and it's effective in doing so because it's just following the data and making data-based decisions. So again, we have two primary focuses for intervention. One is increasing appropriate behaviors, and the other is decreasing inappropriate behaviors. And again, this is kind of a simplified version for the sake of this, but happy to answer more in-depth questions if people have them. So when we're talking about increasing appropriate behaviors, we're focusing on teaching new skills by purposely using cues that are going to signal for a new behavior to occur. And again, the reason why we just spent that time looking at those ABC sequences is because we're looking at teaching these skills, again, through this framework. So if we're going to talk about antecedents, or what happens right before a behavior, we're going to think about how can we create an instructional opportunity that's going to cue the child to engage in a new behavior. And then when we're talking about the actual behavior, we're making sure that we're teaching the right skill or the right behavior given that situation. And when we're looking at the consequence for teaching new skills, we're going to be talking about reinforcement, because this is something that we want the children or the individual to continue to do in the future. So we're going to either provide something to them or take something away that's going to strengthen that behavior and make them more likely to do it again in the future. So just a quick example for this, and this is again through that ABC framework. The parent in this situation is going to do what we call gaining shared control. That means that they're just going to maybe take a piece of the toy that a child is playing with if they're really motivated and interested in it, and they're going to prompt the child to request and ask for that toy. So the behavior is going to be the child requesting and saying ball, and then the consequence is that the parent gives that child the ball back. And so in this case, that consequence, receiving that ball, is going to increase the likelihood that the child is going to say ball the next time they want it. And what we do in ABA is we're going to practice this ABC sequence over and over again until the child is able to do this behavior without having the parent or whoever they're working with have to prompt the child. but again, I just want to point out, as Dr. Chung was mentioning earlier, it's not necessarily the case that the child is speaking and using vocal language. Oftentimes, we're working with children who are maybe pointing to request, or they're communicating through pictures or using some kind of augmentative and alternative communication device. So this is just kind of a basic example so that you can see how that ABC sequence fits together. So I've outlined some examples of commonly taught skills that you're going to find, especially in early intervention. And again, this is just a quick snapshot of some of them that I think cover several of the domains that we've talked about that you would see. And specifically for communication, we might be looking at teaching kids or individuals to engage in communication and talk or use pictures to help get their needs met. So they're maybe asking for the items they want, they're requesting that they need help, they're telling us when they're all done with something. And we're going to talk in a minute about how we can use this ABC contingency to teach replacement skills for challenging behavior. But essentially the idea is that we're going to get the kids to start talking to us and communicating their needs and helping them to have that be really easy and efficient for them so that they're not engaging in more of the challenging behaviors. In addition, you're going to see for social skills, teaching kids in early intervention to initiate greetings, maybe some sharing and turn taking, gaining attention. So again, some of those foundational skills that are really going to help them later on when they're a little bit older, when maybe they start to interact with peers by engaging in reciprocal conversations or those types of things. I won't spend time going through all of these necessarily, but again, the idea is that you are looking to build enough skills into the child's repertoire so that they can be successful later on in learning more advanced skills. And again, emphasizing the importance of really taking a multidisciplinary approach when you're working on these skills. Certainly, it does take a village, and ABA is not a one-size-fits-all. It has a really good scientific process and method for this. But I often find that the most effective treatment are the ones that are collaborative across lots of different disciplines. So when we're looking at kind of the range of interventions that there are for autism or other developmental disabilities, there's really a continuum. And so you're going to hear about structured interventions and naturalistic interventions. And what I like to point out and make sure that people understand is that there is evidence and research to support that both of these are effective. So it's not necessarily one is better than the other, but rather to think of it as kind of a tool in your toolbox. And every person is different. Everyone learns differently. So sometimes it might make sense to use a more structured approach to teaching more skills, and sometimes it might make more sense to use a more naturalistic approach. We're going to talk a little bit about some of the potential advantages and also some of the drawbacks of each one so that you have a little bit more information from that standpoint. But again, this is something that you as parents are helping to have the team decide together in terms of what's going to be most effective for your learner. So when we're talking about a structured approach, we're looking at kind of more of some of that traditional learning that might be more instructor-led. So it's really controlled and paced by the instructor who is presenting opportunities to respond to individual learning trials. Whereas if we're looking at naturalistic interventions, these are things that are really learner initiated and usually are started by requests or gestures for preferred items. So when we're looking at this, it's really getting those kids excited and motivated to engage in the learning with us. When we're looking at structured approaches, this is where you might think of more of those traditional training sessions that are, sit down at the table, the environment and the setting has been arranged in such a way that you're minimizing those distractions. Whereas on the flip side of it, if you're looking at naturalistic intervention, the learning is taking place right within the context of other things that you're doing. And so the environment has the items of interest among all the naturally occurring materials. You know, kind of as Dr. Chung was mentioning before with using, you know, singing to your children and using books and those sort of things, that would be something that would be more naturalistic. You're building that language through their play and those naturally occurring routines, whether it's favorite songs that they like or maybe a favorite toy that they like, that you can incorporate some of the words that they're learning to use. When we are looking at structured interventions, in terms of teaching materials, these are things that usually a teacher is selecting for the child, and they're using reinforcers that are often unrelated to the task. So for example, maybe the child is completing some sort of worksheet and then they get access to their favorite toy. So those two things are not necessarily related. Whereas within naturalistic teaching, the materials that are being used are selected by the learner. So there's good motivation to engage in the task. And what's happening is that you are providing contingent access to those materials based on the responding. So for example, when we were just talking about the ABC sequence involving the child requesting for the ball, you know, what they want in that moment is that ball. So they are gaining access to the ball by using their language. So looking a little bit more specifically into structured models, some of the key characteristics are that skills are broken down into smaller steps. It often allows for repeated practice in a concentrated time period. And again, the trials are not in a natural context, and the reinforcement can be unrelated to a task. So there's several potential advantages of using this type of instruction to teach, you know, whether you're teaching communication or adaptive skills or social skills or any of those other skills we were talking about. One is that there can be faster acquisition rate, right? Because you're allowing for a lot of repetition within a small period of time. Another advantage is that some individuals need more structure to learn. It helps them when the environment is not so busy and they can attend a little bit better to what's in front of them. And in addition, there's typically a very structured data collection procedure that's going to facilitate that close monitoring of progress, which, you know, the benefit is that we can quickly make changes to intervention if a child is not responding because we're watching the data very closely. There are some potential drawbacks. So sometimes there's difficulty with what we call generalization or maintenance. That means that maybe the child learns that skill in that one setting, but then is not, you know, producing that behavior or engaging in that skill in other areas because they've only learned to do it at the table. There's also potentially an increase in disruptive behavior. So sometimes, you know, when we have that high level of repetition, maybe that's boring to some learners. And so sometimes they engage in other behaviors because it's not exciting and motivating to them. And it's also potentially not always developmentally appropriate. So that's something else to look out for. And I've listed a couple of examples of the types of interventions that you would find that would fall under the structured model. In terms of the naturalistic models, some of the characteristics are that the teaching is embedded in the natural environment, like we were discussing. Reinforcement is directly related to the task. So again, there's that good motivation for the child to engage. And it's going to incorporate a developmental perspective. So again, if you have a younger child, maybe this is play-based. It's within daily routines. It can be child-driven. So some of the advantages of this type of intervention is that it's really going to help facilitate that maintenance and generalization of skills. And this makes sense, right? Because the child is learning to produce or engage in that new behavior right within the context of where they're supposed to be actually doing it. So if you were working in the home and you wanted your child to learn all the different parts to setting a table and actually to set the table, you're going to have them practice that right within your household so that really helps to generalize the skill. It also allows the child to remain in their natural environment. And there's oftentimes more parent and caregiver involvement within these types of models. And it can be easily adapted to developmentally appropriate activities. Some of the potential drawbacks of using the naturalistic models are that some kids just don't learn as well with that less structure, right? As we were just talking, some kids really need kind of that cleared environment and not as much stimulation. And the data collection can also be more difficult in natural settings. But again, think of this as a continuum, and these are tools in your toolbox and should be adjusted according to what's going to be appropriate to your learner. So we're going to jump a little bit into talking about decreasing appropriate behaviors. We spend a lot of our time teaching new skills, which are ultimately going to help us decrease challenging behavior. But it's important to keep in mind that behavior is not occurring in isolation, but rather within this context of the ABC sequence that we've been talking about, along with a variety of environmental variables. So one of the things that we're looking at is that there are ABCs that are already happening that are triggering and or maintaining some of the negative behaviors that individuals engage in. And what we're doing as behavior analysts is to look at observing the relationships and coming up with a pattern in order to help us make predictions about why the behavior is happening, so that we can figure out how to develop interventions that are going to be really meaningful. So again, we study those ABCs, we determine ways we might look at changing them, and again, we're going to go back to teaching. You heard me talk a little bit about replacement behaviors before, and that just means what can someone do instead? So instead of crying and tantruming because you can't get what you want, we're going to teach you how to use your words so that you can get what you want. And also, we're often teaching additional skills to support overall functioning. So I'm often looking at helping kids learn really good learning behaviors so that they're ready to be able to engage with a variety of learning opportunities. So these ABC contingencies, as I was saying, are going to tell us why a behavior is happening. And so sometimes functions are not always obvious or intuitive, which is why we have to study and assess them. And it's always important to keep in mind that when anybody is engaging in a challenging behavior, they're doing it because it's working for them. Something about what they're doing is helping them to get their needs met. So again, we want to make sure that we're identifying functions that lead to interventions that focus on the underlying cause of that behavior, so that it can be really helpful and meaningful to that individual. I've listed the four main functions as behavior. So just briefly, gaining attention, that tangible function just means they're getting access to some sort of preferred item. They might be looking to escape some sort of unwanted demand. And there's also what we would call an automatic or sensory function to behavior. So something that that individual is doing that just feels good to them, that they're able to provide to themselves. So just a quick example. So let's say that there's a child in the classroom and that other child is given their snack. But your child engages in the behavior of grabbing that food and that snack from the other child. And the consequence in this situation is that the adult gives your child food to keep them from grabbing the other peer's food. So in this case, that child is grabbing for food because it's working for them and getting their needs met. But if we're talking about teaching a replacement behavior, what we might do instead is look at teaching your child to request for food. So the inappropriate behavior is getting them food, and the replacement behavior is also getting them food. That's very important. It's the same idea, you know, as much as I love my job, I get a paycheck when I come to work. But if somebody is all of a sudden going to just say, hey, Liz, thanks so much for coming to work this week, you know, that's probably not going to reinforce my behavior in the way that you would hope for. So again, making sure what we would call there to be functional equivalence, it just means that that replacement behavior has to help that child get their need met. Again, just quickly, because I know we're running a little bit tight on time, when we're talking about antecedent strategies for decreasing challenging behaviors, we're looking at ways to decrease up the likelihood that the behavior is going to happen. So in the example that I just gave, maybe we're providing the child and his peers snacks at the same time, so that there's no need for the child to engage in grabbing. In terms of teaching behaviors, maybe we're helping them to point to request for food or verbally ask for food. And in terms of consequence strategies, we're looking at what we would call differentially reinforcing. So all that means is that if the child was grabbing from the food, we're going to withhold that snack and not give them to them, but we're going to then help them to use their communication skill and then give them the snack. So we're reinforcing the appropriate behavior and putting the inappropriate behavior on extinction. So just in summary, again, ABA is a science of how environmental variables can change behavior and help us learn. This is happening all of the time, but what we're doing is looking to identify the patterns and purposely using what we know to change those ABC sequences to help teach new skills. And our interventions are defining and tracking behavior systematically and regularly so that they're individualized to our learner and we know that they're making progress. So thank you.
All right, thank you so much for that great presentation. And now we have some time for questions. So if anybody has any questions, feel free to chime in. And I actually have a question that came in through chat. So this participant has a son that's 5 years old and is verbally delayed with about 200 words. They would like to know what your thoughts are on the Touch Chat app as a means of communication, and also your thoughts on prompt speech therapy.
Yeah. You know, so it's a little bit hard to say for specific applications without knowing more about your child. But a couple of things. One, speech therapy is wonderful, and especially speech therapy in collaboration with ABA services can be super beneficial. One of the things that I always like for families and people to be aware of are that there are a lot of prerequisite skills that children need in order to be really successful when they're using any kind of AAC device or some kind of system on an iPad. So anything from visual discrimination to concept formation, those are some of those cognitive skills that I was referring to earlier on. Those are all things that I would check for a child to make sure that they have intact before I'm expecting them to communicate through a device. Because sometimes we run the risk of assuming that a child understands all these different pictures, and potentially what we're asking them to do is rote memorize things instead of attaching meaning to all of those things. So all of that to say is that there's some prerequisite skills that are good to assess and just to check to make sure that they're appropriate for your child. Maybe that's something that somebody has already done with you. But again, that collaboration between speech therapy and ABA therapy can be super beneficial in using those programs. And I've certainly worked with many children who have been very successful on devices when they've had the appropriate prerequisite skills and learning behaviors in place.
Great, thank you. Does anyone else have any questions?
Hi, this is Sujit. I had a question, not related to ABA specifically, but is there any partnership with Dr. Catherine Johansson? She's out of the Danish Epilepsy Center, and I know she's really aggregated a lot of data for SLC6A1. So I know she's overseas, so it's harder, but I just didn't know, because I know I recently sent her medical records, and I know she's had some publications out there, but yeah, just throwing that out there if there's any room to part, because certainly I think she's looked at a lot of casework and data. So I'm not sure if Amber, you by chance know.
I can answer. So there's one published research study that we probably all received when we were diagnosed. I'm not even sure what year it was written, but it only had like 30 or 40 patients, I think. And so it's extremely outdated by this point. She is updating that study with newly published or new cases of the disease. And I've reached out to everybody personally to get their records to her. But she actually is working in conjunction with some other researchers to develop a better understanding of the disease right now. I would just like to stress that it's very, very hard for the patient organization to orchestrate everything. And Sujit, like, you were so incredible from the beginning in making sure the records were sent over. But the faster we're able to get records and necessary information to key people, the faster we'll know more.
Yep, great. And only my 2 cents on that is that, since the sheer volume of data is just, it was a lot. So the way it worked for me is I for my local hospital, I got everything on a PDF file and then on a flash drive, and I literally just FedEx that to her. That seemed to be the best way to get her that volume of data to her. So just for a heads up if anyone is doing the same. So.
Oh, that is so helpful to know. It's been interesting that different doctors and hospitals have had their own protocol of sharing information, but to anybody who hasn't had that out, that is, or been able to get their information out, maybe that would work.
Thanks.
Any other questions? And if there's anyone that's tucked in on mute, feel free to chat me and I can help. But if we don't have any other questions, then we are approaching the end of the meeting time. So I'm also more than happy to wrap up. I just want to give a couple more seconds in case anyone thinks of a question. Okay, all right. Well, that seems to be the end of the meeting. So thank you all so much for joining, and thank you to our presenters and to all of the families that participated in Simon's VIP so that we could present your data back to you. I'm going to go ahead and stop the recording.